video is in section 8.4, and this is the second video on multiplying rational expressions. And in this video, we're going to concentrate on rational expressions that have polynomials in the numerator and denominator. Any polynomials in a rational expression must be factored before you can cancel or simplify or cancel the common factors. So I'm going to factor each of these four polynomials. I'm going to start with that top left, which I've circled in red. So that, first of all, I don't like the fact that that is not in descending exponent form. Descending exponent form is going to be the standard that's going to make your factors look like each other. So what I'm going to do is I'm going to copy that down, and I'm going to give myself some space to factor that. I'm going to write it in descending exponent form, which means that the term with the largest exponent goes up front. And then before I try any other method of factoring, I'm going to look for GCF. The GCF of this polynomial is -5. Anytime the first term of a polynomial is negative, the GCF should be negative. And it should also include an x, because there's an x in both terms. So I want the smallest exponent of that common variable. I'm now going to divide -5x out of both terms. So I have -5x to the second divided by -5x gives me +1x. And now I have 20x divided by -5x is -4. All right, so that is the top left polynomial in this multiplication problem. Now what I'm going to do is I'm going to factor the bottom left, the denominator on the left. That one's already in descending exponent form. That one has a GCF. The GCF is x. There's an x in both terms. X to the power of 1 can be divided out of both terms. So x to the second divided by x is x. And then the negative x divided by x is -1. On the top right, another polynomial. This one does not have a GCF. It has 3 terms and the leading coefficient is 1. So I'm going to use EZAC. I'm going to look for factors of -4 whose sum is +3. 4 times 1 is 4. If I do 4 minus 1, I get 3. And 4 times -1 is -4. Those are my magic numbers. So I'm just going to substitute them in. And then let me see if I can find another color. All right, so the color I'm going to use for the denominator is going to be purple. All right, so here I've got the difference of 2 squares, x squared minus 16. Both terms are perfect squares, and it is a subtraction, so it's the difference of 2 squares. The square root of x squared is x times x, or x, and that's your first times first. The square root of 16 is 4, and that's your last times last. 1 minus, 1 plus. After you have each of your factors, each of your polynomials factored, we're going to look for any common factor that's in the top and the bottom. We're going to cancel them out. So first I see an x on the top and x on the bottom. Those are monomial factors that can be canceled. X can go away. I've got an x minus 4 on the top and an x minus 4 on the bottom. They can cancel. I have an x plus 4 on the top and an x plus 4 on the bottom. they can cancel. And I have an x minus 1 on the top and an x minus 1 on the bottom. They can cancel. I just love it when these problems, everything cancels out. The only thing that I'm left with in all of what I've just done is a negative 5. Everything else has canceled. And my final simplified version of this two polynomials or two rational expressions multiplied together is only negative 5. Negative 5 is the answer. They don't always cancel out so much. Sometimes you're left with more. Okay, here's my second problem we're going to try. And again, I always encourage you on some problems that you've already seen, give it a try by yourself, pause the video, and then check your work with mine. All right, so I'm going to start by factoring the top left. And that it has a GCF of 2x. I'm going to divide 2x to the second by 2x. I get x. I'm going to divide negative 10x by 2x. I have negative 5. Now to the bottom left. That has two terms. They're both perfect squares. And it's a difference. So we've got a difference of 2 squares. The square root of x to the second is x. That's your first times first. And the square root of 25 is 5. That's your last times last. 1 minus, 1 plus. X plus 3 has two terms. It is not the difference of squares because they're not perfect squares. It is not the difference or sum of cubes because they are not perfect cubes. You cannot pull out a GCF. So every factoring method I know does not work on that one. So I'm going to think that that's prime. It's already in factored form. And now my monomial, the 2x to the second, it doesn't have a plus or a minus, so it doesn't need to be factored. It's already considered to be in factored form. All right, now I'm looking for things that can cancel. I'm going to cancel in purple. Okay, here we go. So an x, 2, let's start with 2. 2 cancels. One of the x's cancel, so x on the top, and I've got x to the second on the bottom. I'm going to subtract those exponents, and on the bottom, I'm going to be left with an x to the power of 1. X subtract 5 cancels, and I think that's the only thing that will cancel for this problem. So I'm left with x plus 3 up top, that's coming from here, and then I've got an x, that's right here, x to the power of 1, goes on the bottom, times x plus 5. Now the x plus 5 has to stay in parentheses. If you have more than one factor in your answer, we've got to put the polynomials inside parentheses. All right, next problem. Okay, so here I have a rational expression. This is rational because it's a fraction. And then I have just a plain polynomial. Well, any number is equal to itself over 1. So what we have to consider is that second term, the second polynomial, x squared plus x plus 1, is the numerator, and the denominator is 1. I'm going to start by factoring the top left, x plus 5. That has two terms. It has no GCF. Those terms are not perfect squares or perfect cubes. So that is prime. It can't be factored. I'm just going to bring it down. Now I'm going to factor the bottom left. All right, this has two terms. They are both perfect cubes. X to the power of 3 is a perfect cube, and 1 is a perfect cube. It's 1 times 1 times 1. So we're going to use the difference of two cubes to factor that. So the cubic root of x to the third is x. The cubic root of 1 is 1. And so I'm putting that into the formula. I've got your cubic root of the first term, cubic root of the second term, and now I'm going to square a. I'm going to add 1 times x multiplied together, that gives me x. And now I'm going to square this last term, and 1 squared is 1. All right, now in blue, this is going to be the numerator. Okay? That has 3 terms. There is no GCF. The leading coefficient is 1. So that's not factorable. That's easy AC. I tricked myself there for a second. I need factors of 1 whose sum is 1. Well, 2 numbers that multiply to 1 are 1 and 1, but they don't add to 1. All right? So that's not factorable. All I'm going to do is just copy that down. X squared plus x plus 1. And I got a little bit tricked by my own question here for a second. I thought, oh my, it's not factorable, nothing's going to cancel. But then I realized that that whole polynomial, all 3 terms, cancel with this trinomial on the bottom that I got from the difference of 2 cubes. Okay, I don't think anything else cancels, so I'm left with an x plus 5 up top. I'm left with an x minus 1 on the bottom. And that's it. That's it for this video.